Hi folks, Mr. Long here. We're going to do a screencast on developing the derivatives of the inverse trigonometric functions. Okay, developing the derivatives of the inverse trigonometric functions. So it's going to involve a little bit of review from the last couple of screencasts, but also some connecting back to what are called implicit derivatives. Okay, let's go. So first thing I'm going to do is some Pythagorean theorem here for this side here again, which I will call L. Well, we actually also know it's the adjacent side. Maybe we'll just call it adjacent. So we know that the adjacent squared would equal 1 squared minus x squared, okay, which is going to equal square root of 1 minus x squared. Okay, so what's our relationship here? What is our relationship? So we're working with sine here. So if I'm working with sine, that means that y, sine of angle y, equals x over 1, right? Sine of angle y equals x over 1. I think we all agree that that's true, right? So sine of y is opposite divided by hypotenuse. Now, x over 1 can just be x. So I can rewrite that as sine of y equals x. Now what I need to do is differentiate both sides. So remember, when I differentiate y, I have to write y prime. So what I'm going to do here is I'm going to differentiate sine of y. Well, I write y prime followed by cos of y, because that's the derivative of sine y. The derivative of this x is 1. How do I isolate for y prime? Well, I write y prime equals, and I divide both sides by cos y. So divide by cos y. And when I do that, I'm going to get 1 divided by cos y. But I don't want to have a derivative defined in terms of y. I want the derivative defined in terms of x. But can I go to my triangle now and do that? So let's think about this for a second. What's cos y worth? Cos y is adjacent divided by hypotenuse. So cos of y is square root of 1 minus x squared divided by 1. So we now know that y prime equals 1 divided by cos of y, and cos of y is adjacent divided by 1. So it's 1 divided by the square root of 1 minus x squared. Okay, and that's your derivative for sine inverse of x. Okay, and there it is right there. D by dx sine inverse of x, or arcsine of x, is equal to 1 over 1 minus x squared. What I'm going to do now is develop, I'll go and develop tan, and again have you develop cos. Okay, so for tan's the trickiest one to develop, I think. So for tan, what we want to do is, again, let's figure out what this third side is, the hypotenuse. So we would say the hypotenuse squared would equal 1 squared plus x squared, right? So the hypotenuse equals, square root both sides, it's 1 plus x squared, and that's our hypotenuse. So what I'm working with here is tan. So tan is opposite divided by adjacent. We know then that tangent of angle y equals x over 1. Really, tangent of y equals x. Let's get the derivative now. So if I'm going to get the derivative of this, I'm getting the derivative of tan, but I'm getting the derivative of y, so I have to write y prime. So I'm going to write y prime first, and then the derivative of tan is sec squared y. And then the derivative of x is just 1. So what's another way to write sec squared? Well, that means it's y prime all over cos squared y equals 1. Now, if I multiply both sides by cos squared y, that would allow me to isolate for y prime. So y prime equals 1 multiplied by cos squared, which is just cos squared y. But again, I don't want a derivative defined in terms of y. I want it defined in terms of x. So what is cos worth? Well, let's take a look. In this case, cos of this angle y is adjacent 1 divided by hypotenuse right there, right? So it's 1 divided by the square root of 1 plus x squared. 1 divided by the square root, like adjacent divided by hypotenuse. So let's write that down. So that equals 1 divided by the square root of 1 plus x squared. But it's squared because of that square there. So y prime then equals, y prime equals 1 squared followed by square root squared. So it's just 1 over 1 plus x squared. And that's the definition of the derivative for tan inverse, okay, which we see here. The definition of d by dx tan inverse is 1 over 1 plus x squared. So what I'd like you to do now, whoops, is just if you could come down to sorry, this right here, so where we're doing cos inverse, and I'd like you to use your handout to develop the derivative for cos inverse based on what you've learned in sine and tan. Okay, so I'll pause the recording and then give you you can pause the recording and take a minute and then continue on. Okay, folks, so let's finish this off then. So here's the development of cosine inverse, the derivative of cosine inverse x, and it's right here. It's located in this box here. So take a look at that, make sure that you've got it correct. You can pause this right now, in fact, and make sure you've got it. That's the definition of it. So d by dx of cos inverse of x is negative 1 over 1 minus x squared. So what you'll notice is that it's exactly the same as the derivative of sine inverse of x, except for that little negative there. Okay, and that's really nice when it comes to integrals, because when it comes to integrals then, whoops, we don't have to worry about so right here, when it comes to integrals, it's very, very easy. We only have to worry about one integral. So if you notice, and just think of it as the antiderivative, right? Just think of the antiderivative. So there's the integral of that. Oh, I should have a dx there, and there should be a dx there. The integral of 1 over the square root of 1 minus x squared is sine inverse. But what if you had this? What if you had the integral of negative 1 over square root of 1 minus x squared dx? Well, you could write that as cos inverse, or look at this. You could actually take that negative and bring it outside the integral sign, put it here. That would be a plus sign, and then that would end up being negative sine inverse of x plus c. Okay, so interesting that that negative sign can be interpreted as a cosine inverse function or a sine inverse function. And if you were familiar with the graphs, you would see why. They're actually vertical reflections of each other, which makes sense. But we're not really going to go into the graphing this year. That's something that we'll leave for you for something new for next year. Okay, so let's go on now and start doing some examples. Actually, I think what I'll do now is just stop this video, and the next video will be examples of derivatives.